This video is about sampling and the population and serves as a good introduction to research and to the ways in which data can be collected from populations. So let's start by talking about sample and populations. So we're looking here to take a sample from the population. Perhaps it's too expensive to interview everybody in a population or to investigate every item in a population. So taking a sample means it cuts down the cost, and it also means that if the sample is of a significant size and properly drawn from the population, that the sample will be representative of the population and hence can be relied upon to give an insight into the various parameters of the population. So the target population should be identified through the use of judgment. So the first point to note here is that the target population must be identified. What is it the researcher is interested in? Is it in a particular set of customers or people living in a particular area? Is it based on gender, on age, on some sort of demographic? What is it the researcher is interested in? And once that has been determined, the population can then be selected. The population can be identified. Normally it's done through judgment. It's done through the purpose of the investigation. If the research is into teachers' attitudes towards curriculum development, then the relevant population will be teachers, quite obviously. But other people may be interested in curriculum development. Parents may be interested in it as well. So the fact that the teachers were selected illustrates judgment on the part of the researcher. The researcher has decided that the relevant population would be teachers, not the parents. The population is defined through the objectives of the study. So it's important to look at the purpose of the study and then identify what the population should be. Look at what's the study attempting to do, what's attempting to find out, and then decide on the population. If the entire population is sufficiently small, then the researcher may include the entire population in the study. It depends on the size of the population. Once a particular population has been identified for investigation, then its size must be considered. If only a few exist in that population, then perhaps the researcher could deal with the whole population. There's no sample required. The population is so small, there's no need. But of course, if the population is large, then a sample will be required to cut down the costs, to speed up the process. Of course, in selecting the sample, we have to bear in mind that there are possible errors, possible misleading traits associated with the sample. This sample may suggest that the average is a particular level, whereas the true population may be slightly different. So there are errors involved in sampling. The type of research is called census study because data is gathered on every member of the population. So if it is based on the entire population, if the investigation is based on the entire population, it's called a census study because everyone's included. Like when the government has a census of the population, it's required that every member of the population should complete the forms and should participate. So everyone in the country is covered in a census survey. But if the investigation was into people who buy a particular product, if every person who buys that product is contacted, that's a census study. Census means everyone in the population is contacted. Usually, however, the population is too large for the researcher to attempt to survey all of its members. Generally speaking, populations may be very wide-ranging and may also be distributed geographically, which will further increase the cost of trying to investigate every member of the population. So populations tend to be very large, and for that reason sampling is used. A small but carefully chosen sample can be used to represent the population. So a small sample, let's say 30, perhaps the population is 100,000, 30 people could give an insight into the population of 100,000. A small sample of that size can be useful. It depends on how it's collected. Each member of the sample should be selected in a way which is random. If they are randomly selected, then they tend to represent the whole population. Clearly, the bigger the sample size, the better the approximation to the population. So if instead of selecting 30, the researcher selected 100, that would give a better picture. And there should be some rule, as indeed there is, about what the ideal sample size should be. But generally speaking, the most important point here is that the sample should be selected randomly. And by random, I mean every member selected has an equal chance of selection. Every member of the sample has an equal chance of being selected. That's the important point to bear in mind. The sample must reflect the characteristics of the population from which it is drawn. So it should not depend on the opinions of the researcher. The researcher should be neutral, and each member of the sample should have an equal chance of selection. Sampling methods are classified as either probability or non-probability. There are two types of sampling method. In probability sampling, each member of the population has a known non-zero probability of being selected. In other words, each member of the population has the possibility of being selected. If they had a zero probability of being selected, it means they could not be selected. They have no chance of being selected. So each one has a non-zero probability of being selected. Every member of the population has a chance of being selected. That's with probability samples. And probability methods include random sampling, systematic sampling, and stratified sampling. In fact, there are others, but these three are the main ones. And as I said earlier, ideally every member of the sample should have an equal chance of selection. And every member of the population should have an equal chance of selection, perhaps I should say. So every member of the population has the chance of appearing in the sample. Systematic sampling is a way of reducing the cost by picking perhaps every 10th member of the population, or every 100th member of the population. So it cuts down the cost of sampling. And stratified, it could be looking at particular characteristics. So it may take some male, some female, some people over 50, some people over 40 but less than 50, and so on. So it's stratified. Again, ideally it's to ensure that different parts of the population are represented in the final calculations. So there are different types of probability method. These are the probability methods. Now, non-probability sampling, these could include convenience sampling. convenience, as the word suggests, simply use a convenient technique. Perhaps ask your next door neighbour. It's not very reliable, as you can imagine. It's very biased, and for that reason it's criticised, and quite rightly it's criticised, because the outcomes of this sampling technique are not very reliable. It's just convenience. It could also be judgment sampling, which means the sampler just uses his or her judgment in selecting the sample. So again, it's biased, because the sampler, the researcher, may have particular opinions and may not reflect the true value of the population simply by, in a sense, discriminating against certain members of the population appearing in the sample. So judgment sampling is very suspect. It means the researcher is using his or her judgment as to who should be included and how the sampling should be conducted. Next, quota sampling, just simply working to a quota, working to some particular level, working to, so 5% of the population will be sampled, and no more, no less. Snowball sampling is not very reliable. It's that's when you ask someone, and you ask that person to recommend some of his or her friends to answer the questionnaire as well, or to participate in the sampling exercise. And then you contact his or her friends and you ask his or her friends to recommend their friends. So it's snowballing. The sampler, the researcher, is simply asking for referrals to move onwards. Again, not very scientific and not very reliable. So let's look at sampling errors. These are errors that arise out of the sampling technique, and which means that the results of the sampling is different from the true values of the population, which is what we were trying to discover. Sampling error is the degree to which the sample might differ from the population. That's the sampling error. It's the difference between what the sample has thrown up and what the population actually is. When referring to the population, results are reported plus or minus the sampling error. So when we conduct a survey and we find that, say, the average is a certain amount, what we would say is that the population average is equal to the sample average plus or minus some percentage, or plus or minus some figure. We know that the population is near the sample, but it may not be precisely on, so we give it in a range. We say it's equal to the sample average plus or minus whatever, plus or minus 5% or plus or minus 10%. Depends on how confident we want to be about our predictions. In non-probability sampling, the degree to which the sample differs from the population remains unknown. Non-probability, for example snowball sampling, it's just a figure. We don't know how representative that is of the population. It's generally speaking not very representative. Sometimes on the news, on television, reporters who are reporting on an event want to get an opinion about, let's say, government policy. Let's say the government's introducing a new policy, and the reporters want to get an opinion about this. They may just stop someone standing outside of the House of Parliament. Well, that's very biased. The person standing outside of the House of Parliament, outside of where the government sits and makes laws, that person may have a vested interest, or that person may be critically aware of the importance of this change that the government's introducing. But what about the people who live at the other end of the country? Should their opinions not be taken into account? So what the reporter has done is just convenience. There just happens to be someone there and they ask what they think of it. But that doesn't mean it's representative of the population. Random sampling. Well, this is the purest form of probability sampling. Each member of the population has an equal and known chance of being selected. So each member of the population has the possibility of being selected, as I said earlier. And this is the best form of sampling. It's also the most expensive and the most complicated. When there are very large populations, it's often difficult or impossible to identify every member of the population. So the pool of available subjects becomes biased, and that's a problem. Sometimes we can't identify the whole population. Let's say someone who's interested in wildlife and they wish to try to work out the characteristics of a certain species. They're interested in looking at the population of foxes. Well, it's difficult to work out the population of foxes. They don't all just stand there and wait to be counted. Foxes live out their lives running around and being foxes. So simply by taking a sample in a particular area, by counting up what they've seen in a particular area, doesn't mean they can estimate what the population is. So sometimes it's very difficult to identify every member of a population. And also with us as humans, sometimes we keep our opinions private, we keep them secret. We don't want to discuss our opinions. So again, it's very difficult to work out the population who hold a particular opinion. So random sampling has got problems. Systematic sampling, it's often used instead of random sampling. After the required sample size has been calculated, then every nth record is recorded from a list of the population members. So every nth means we could count up every 10th or every 100th member of the population and interview that 100th or look at the characteristics of that 100th element. So we're not doing everybody. We're not counting up everyone in the population. We're taking every, let's say, 10th person and asking that person their opinions, or looking at every 10th item. If it's looking at the population of industrial output, taking every 10th car that comes off the production line and testing it for quality. Taking every 100th car that comes off the production line and testing it for quality. So we're picking a particular number and we're doing it systematically. It cuts down the cost. We're not spending all our time trying to work out what the true nature of the population is. It's cheaper to do. It's quite straightforward. But of course, the figures that we calculate may not accurately represent the true population. There may be significant bias or significant error in the calculations. As long as the list does not contain any hidden order, the sampling method is as good as the random sampling method, or at least it's often suggested to be as good. It's not truly as good. I mean, what I've got written on the slide there is perhaps too strong. The best is random sampling. That is the best. Systematic is good, providing there's no order to it. We would be very unfortunate if we were looking at, let's say, the output of cars in a car factory, and we picked every 20th car to test, and we start with a particular one and we find that it's got a fault. It's got a fault in some part, in the steering. And now we go to the 20th item. So we've jumped from that one, we count on 20 and we go to the next one. And we find there's also a fault in the steering. And then we count on 20 again and we test it and we find there's another fault in the steering. Now this would suggest that all the population, all the cars have got a problem with the steering. But it may not be the case. It could be the case, it's very unlikely, but it could be the case that just every 20th car has a problem with the steering. Very unlikely, but it is a possibility, and it's worth considering. Its only advantage over random sampling technique is its simplicity. That's the advantage that systematic sampling has got. It's frequently used to select a specified number of records from, say, a computer file. So often when sampling is done on a computer, the computer is told to select every 50th file or every 20th or whatever, and the computer can do this. A computer can also random sample, of course. It's not true random sampling. True random sampling means every element in the population has an equal chance of equal probability of being selected. Computers can't do that. Computers have to follow what's known as an algorithm. They have to follow a rule. And for that reason, they're following a rule. It's not random. So random sampling is like drawing balls out of a bag. Each ball in the bag has an equal chance of being selected, providing that each ball feels the same, has the same physical characteristics. If the person selecting can't see into the bag, they put their hand in the bag, each ball has the same probability of being selected. That's random sampling. With a computer, it follows a rule, it follows an algorithm, and therefore it's not truly random. It's following a program. Admittedly, random sampling on computers, or what's known as pseudo-random sampling, is very good, and that's what enables us to have games on computers. Games have random or pseudo-random components built in to make them interesting, but they are not genuinely random. That's the point. Stratified sampling. Well, this is commonly used probability method, and is superior to random sampling because it reduces sampling error. It's said it's superior. Again, that statement may be misleading. Random sampling is still the best, but this one it does attempt to include all parts of the population. So in that sense, it's seen as superior. So it looks at, let's say in the car example, in the car factory, it looks at all the makes of the cars that are made in the factory, not just one particular car. Random sampling could end up just testing one particular make of car, one particular model of car. Just coincidentally, it just selects one particular model and tests it because it's random. But with stratified, a rule will be set in place that different models of cars should be included in the sampling process, and for that reason it's seen as superior. But whether it is or it's not is debatable, and I tend to subscribe to the fact that random sampling is still the way forward. That's probably the best method. A stratum is a subset of the population that share at least one common characteristic. So a stratum of this stratified sampling, a stratum is the basis for selection. It could be in the car example that models share a particular production process, or they're built within the same factory unit, or they're built to a particular design. They share some common characteristics. So it's a stratum of the output of the factory. If we had stratified sampling amongst people, amongst the general population of people, then we might want to make sure that males and females are included. So if it's random sampling, it could be coincidental that just all females were selected or all males were selected, and therefore the results could be lead to a considerable error, considerable bias or error in the sampling procedure. So to avoid that happening, the researcher may decide to have 50% male, 50% female. But then people older may have different opinions than younger people. So again, it may be subdivided, that it could be older males, older females, younger females. So again, it's introducing different strata to try and get a more representative picture of the population. So that's the idea of stratified sampling, to try and include different parts of the population and to guarantee that they are included. So as I said, the stratum, or the strata I should say, might include males, females, managers, non-managers. The researcher first decides the relevant strata and their actual representation in the population. Random sampling is then used to select a sufficient number of subjects from each stratum. So having worked out the strata, then it's random sampled within the strata, which gives the stratified sampling. So it is seen as superior to random sampling in the sense that it at least guarantees that all the different parts of the population are represented. It's sufficient means sufficient in this case means a sample size large enough to give confidence that the stratum represents the population. So a sufficient number have to be selected to give confidence that the sampling is representative of the population. Clearly the size of the sample must be sufficient to give confidence. If we were talking about the human population of this country and only 10 people were selected and sampled, that's not representative. It wouldn't give a lot of confidence. If 1,000 people were selected, there may be more confidence. Convenience sampling. Well, this is non-probability. This is used in exploratory research where the researcher is investigating in getting an explicit or implicit, I should say, an implicit approximation of the truth. Convenience is the researcher just trying to figure out what's going on, trying to figure out the characteristics of the population and just taking what is convenient. There is no real effort involved in this. It's what's available and looking at what's available and trying to work out some characteristic of the population from what is easily available. It's convenience. As the name implies, the sample is selected because they are convenient. It's a non-probability method, often used during preliminary research efforts to get a gross estimate of the results without incurring the cost or time required to select a random sample. So sometimes it's used at the very start of a research activity to try and gauge roughly what the population size is, or roughly what the different strata in the population are. So it's normally some rough estimates at the very start of a research program, a research activity, to try and work out population characteristics. Judgment sampling. Well, this is a common non-probability method. The researcher selects the sample based on judgment. and hence, of course, it's biased. It reflects the opinions, attitudes, ideas of the researcher. The researcher doesn't like certain people, doesn't like their appearance. Those people may not be included in the sample because the person has decided that he or she doesn't want to talk to them. So it's judgment. It could be that they want to investigate some characteristic of the population, but some of the people live in inconvenient parts. They live on the top of tower blocks, and they don't want to go all the way up to the top to interview them, or they live out in the countryside and they don't want to travel all that way to try and just interview one person. So they're using judgment, but of course it is introducing bias. It may be seen as an extension of convenience sampling. It's like convenience sampling, except now the researcher is using his or her judgments as to who should be included in the sample. If it's in the car example, looking at car production, looking at the quality of the car production, judgment sampling might be someone saying we'll sample this car and that car and the one over there. Well, why? It's simply because somebody just said this one, that one, and the one over there. It's his or her judgment, but it does introduce errors. So, for example, the researcher may decide to draw the entire sample from one representative city, even though the population includes all the cities. That's judgment. Somebody's just used their judgment to select one city. In fact, when they've got the results from that one city about people's attitude towards something, then they say, in that country, these people's attitudes are. Well, they didn't sample the country, they just sampled one of the cities because someone used judgment. When using judgment sampling, the researcher should be confident that the chosen sample is representative of the entire population. So the researcher must bear in mind that by using judgment, he or she is not selecting parts of the population, and they must have confidence that that's not going to damage the results significantly. Quota sampling. This is a non-probability equivalent of stratified sampling. Like stratified sampling, the researcher first identifies the strata and their proportions as they are represented in the population. So they must look at the different strata. So if it's an attitude survey about people's attitudes towards government policy, let's say, then they must identify the different strata by gender, by age, by location, by occupation, by education. They must look at the different strata of the population and then try to work out how many from each should be included. When convenience and judgment sampling is used to select the required number of subjects from each stratum, when the convenience is done, or judgment sampling is done, from within each strata, the overall picture can emerge. So what quota sampling is doing is breaking up the population into different strata and then taking a quota, taking a number out of each one. It differs from stratified sampling, where the stratum are filled by random sampling. So with stratified sampling, the strata were identified and then randomly sampled. With quota sampling, they simply identify the different parts of the population, the different strata, and then select a number out of that. That number could be selected on the basis of judgment. It could be the researcher saying, yes, we've identified people from different genders, different age groups, different locations, different occupations, and so on. and then they go to interview some people from the different strata, but it's not done randomly. So quota sampling is not really random, it's more trying to include different opinions from different parts of the population. Snowball sampling, again a non-probability approach, used when the desired sample characteristics is rare, when the characteristic is rare. Sometimes people want to find out particular opinions about something. Let's say a sport. They want to find out what people's opinions are about rock climbing. Now it's a highly specialized sport, people climbing very dangerous rocks. So snowball sampling may be the best approach, because where do you find a sample of rock climbers? There might be rock climbing clubs who will help, and there might be sources online that will help. But a lot of the time it's a question of finding someone who is a rock climber, asking his or her opinion about some aspect of the sport, and then at the end asking him or her to recommend their friends as sources of information, and go and interview their friends about rock climbing, and then ask their friends about rock climbing, and ask their friends to recommend more friends. So it's snowballing, and it's picking up opinions in that way. It may be, as I said, extremely difficult or costly to locate respondents in certain situations, because they're not a big part of the population. Snowball sampling relies on referrals from initial respondents to generate additional respondents. So it's snowballing out. While the technique can dramatically lower search cost, it comes at the expense of introducing bias, because the technique itself reduces the likelihood that the sample will represent a good cross-section of the population. It could be the case that by asking someone, say rock climbing, about some aspect of the sport, they've got a particular view of the sport, a particular, perhaps unusual view of the sport. They like it because it is extremely dangerous. That's what attracts them. And they recommend their friends, who also like it because it's extremely dangerous. Other people may like it because it's a challenge, it's an intellectual challenge, how to get up the rocks safely. Other people may look at it as a good source of exercise. So different people come to the sport with different views. But simply asking someone to refer their friends, the chances are their friends will have the same opinions as them. They're friends after all. And their friends will have similar opinions to them. So you're picked up on a line of people who share a common view. And that, of course, will introduce bias. So the types of sampling, well, we have probability and non-probability. If you remember back, probability, simple random sampling. Then we had stratified sampling, looking at the entire population and then breaking it down into different strata and interviewing randomly each person within the strata. And we also have cluster sampling. Cluster sampling is cluster random, means picking up on a particular area, let's say, going to a particular area and looking at the characteristics of that particular area and interviewing people within that particular area. That would be a cluster. Or trying to find people with particular characteristics and trying to interview those, and that would constitute a cluster. The whole idea is, in some respects, is to get representative information about the population, but get it as cheaply as possible. And we also have systematic random sampling. Systematic random sampling is picking up every, let's say, tenth car coming off the production system in a car factory. Well, that's good, but it's necessary to find out which car do we start from. So we start from the one which is randomly selected. Non-probability, we have convenience, judgment, purposive, as it's sometimes called, quota sampling, and of course snowball sampling we talked about earlier. So these are the different types of sampling, and it's worth making notes on each one. Just a short amount of notes, short paragraph on each one, exactly explaining what each type of sampling is, what are its essential characteristics. And go back over the notes and do some research into that. But that's all I'm going to deal with in this class. So as I said, it's worth going back over the PDFs, back over this particular session, and seeing what each type of sampling is. Make your own notes. And that's it for this session, so thank you for watching.